Hi again. Here is a short and sweet video to show you how you get the derivative of z with respect to wj. And this is super satisfying because you'll get to cross out lots of terms and end up with just the variable x sub j. Let's take a look. So here's the expression we saw in the last video. We want to get the derivative of the loss with respect to wj, and we can do that by taking these three derivatives and multiplying them together. So here in this video, we're going to figure out how do we get the derivative of z with respect to wj. And it'll end up being this expression. It will just be the feature x sub j. So remember that z is w dot x plus b, where w is a vector, w1, w2, including wj, for example, maybe j is 3, for instance, all the way to wn, where n is the number of total features. And x is also a variable of all the features, x1, x2, including x sub j, all the way to x sub n. So z can also be written this way with scalars, w1 times x1 plus w2 times x2 plus so forth and so forth, wj times xj plus all the way to wn xn and also plus b. And I'd like you to pay attention to this particular term, wj xj. Now when we take the derivative of z with respect to wj, what we actually do is take the derivative of each of these individual terms. So derivative of w1x1 with respect to wj, and derivative of w2x2 with respect to wj, and so forth and so forth. Now what's interesting is that the derivative of that first expression with respect to wj is 0, because you actually don't have wj anywhere in there, and don't worry, this is just a rule of calculus that you can look up. And so similarly, this second expression is also 0 because wj does not appear anywhere in the w2x2. Same thing with wnxn, and same thing with b. So all of these turn out to be 0. So here, this expression simplifies to just x sub j. And here's just a quick reminder of calculus rules for why this is the case. The derivative of w times x, where w can also be written as w raised to the power of 1, the derivative of this with respect to w is w raised to the power of 0 times whatever else is left over, which is x in this case. And any number raised to the power of 0 is just 1. And that's why you just get whatever's multiplied to the wj, which in this case is x. And so that is how you get this expression here that you saw in the previous video. In the next video, we're going to show you how you get this other middle term, the derivative of f with respect to z. So please go on to the next video to see how to get that one.